Today we're talking about general solutions to any type of trig equation. So yesterday when we did, when we did the inverse values, we were just finding two of the overall solutions. Now we're going to see how to find all of the solutions to an inverse trig function. This is going to be very similar. We just are going to add one extra step to it. So let's start on number one. So again, this is going to be the same steps as I did yesterday. I'm just going to take this inverse sine of root 3 over 2. So my first step is always to draw my triangle and label it with the side lengths they gave me. So for this one, I know that this is positive, so it's going to be in quadrant 1 because that's the first place that sine is positive. And then I'm going to label my side. So this would be opposite over hypotenuse. So my opposite side would be root 3. My hypotenuse would be 2. That would make my last side 1. And I know that now I can find my reference angle. So after you have drawn your triangle, you're going to find the reference angle. So when I look on this guy, my reference angle would be the side that's opposite my root 3 would be my 60 degree. And in radians, that guy is going to be pi over 3. Okay, so once you've found your reference angle, you have to remember that since this is a positive sign, we can actually find two solutions to this. So now you're going to find the other quadrant. And so when I look at my all students take calculus, I know that the other place sine is positive is where y is positive, so it should be in quadrant 2. And again, it'll be the same reference angle on the triangle. I've just got to figure out how far I went there. So this is pi over 3, but in the second quadrant, it would be 2 pi over 3. So that's how we found the inverses yesterday. So for a general solution, all we're saying is we want to be able to find all of the answers to any of these equations. And remember, the easiest way to find another angle that gives you that same trig value is to continuously go around and around and around and around your circle. So for a general solution, all you need to do is add 2 pi or 360 if it was in degrees, any number of times. And so the way that we denote that is we're going to take the value that we know. So we found my first solution to be pi over 3, and I'm going to add 2 pi, and I'm just going to say times n. That's any number of times. So I could add 2 pi times a million, and that would still be a solution and I would find a angle that had root 3 over 2 as its sine. So I have that for the first one. I'm going to do it again for the second one. So 2 pi over 3, and again, I'm going to add 2 pi any number of times. Okay, this n could be positive or negative, so I could be subtracting 2 pi as well. So again, in order to find all your solutions, you're just going to add a 2 pi into the end. They're also going to ask you sometimes to find the first 3 positive solutions, which is really nice because we already kind of did that. We found 2 of them. We found that the first one that we could get to was at pi over 3. The second one that we could get to was at 2 pi over 3. And now we've got to go around that circle one more time, and we've just actually got to add the 2 pi to that first solution. So I'm going to take pi over 3 and add 2 pi times 1. And so again, I've got to find a common denominator here. So this would be over 3. So I would times that by 3 as well, so 6. So my next solution would be 7 pi over 3. So again, when you're finding your first 3 positive, you just are looking for the next one in the sequence. Let's look at another example. Okay, so now we have this one. We have x equals the inverse sine of negative 1 over 2. So the first thing I notice in this problem is that we have a negative sign. And so the first thing I always try to do is I want to figure out where my general solutions are going to be. I'm going to have a negative sign, so I need to find my one answer in quadrant 3 and one answer in quadrant 4. So my first thing I'm going to do now that I have an idea of what I'm looking for is I'm going to draw my triangle in the correct quadrant. So my first one's in quadrant 3, so I'm going to go ahead and draw that in there. And I'm looking for this one also, okay, in quadrant 4. I'm going to actually start in quadrant 4 just because it's over here. So sine is opposite over hypotenuse. So my hypotenuse will be positive, and my other side would be negative. And again, I think about this guy, this would be root 3, and opposite my 1 should be my 30-degree reference angle. Now, the easiest thing I can think of to do right here is instead of trying to figure out going all the way around in quadrant 4, we also could write this as a negative value. So this would also be negative 30 degrees or negative pi over 6. So I am allowed to use negative angles on the general solutions because I didn't say between 0 and 2 pi. So again, if you want to find that in quadrant 4, you can just say negative reference angle. So for my first general solution, I'd have negative pi over 6, and then again, I can circle around and find as many as I want. So plus 2 pi n, and then again, I can go find this other guy, and I could make it negative 5 pi over 6, or I can just go around the circle and find the other one. So then I'd have that would be 7 pi over 6. Again, it should have the same reference angle, and then we're just going to figure out what quadrant it goes in. So these are my general solutions. If they ask me to find my first 3 positive on something like this, where I went ahead and I made one of them negative, my first positive going around the circle would have been 7 pi over 6. To find this other one, since now I have a negative angle and I can't use that one, I would actually take negative pi over 6 plus 12 pi over 6, or figure out what that was in that right quadrant. And again, I'm finding a common denominator, so 12 over 6 is going to be the same thing as 2 pi, so my next one would just be that first one plus 12 pi over 6. So these are my first 3 positive. Okay, so if I look at something like this one, cosine of x equals negative 1/2, this looks a little bit different than the ones that we've been doing. Remember, to find this x, to get this x out of here, you can't just divide by cosine. You're never ever going to divide just by a cosine. You have to divide by cosine of something, and that's going to make my equation crazy. If I want to get x out of here, I'm going to take the inverse of both sides. So if you make a note of that, take the inverse. Wow, there goes my handwriting. Both sides. So if I take the inverse of this, I will go inverse cosine of that, and then on the other side, I'll just distribute my inverse. And so again, if you have an inverse of a cosine, that just gives you the x, and then I'm going to be finding the inverse cosine of negative 1 over 2. So again, I'm looking for those angles that give me that particular cosine. So I want you to go ahead and try this one on your own. Okay, so pause the video right here. You try. I'm going to write the solutions up, so make sure you know how to do it. Okay, but pause it. I'm serious. Pause it right here. Okay, here are your answers. These would be the first 3 positive solutions for this. And so if I wanted my general solutions, it would have been 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n. Okay, let's look at one of them that are a tangent equation. So on number 4, it says the inverse tangent of negative root 3. So the first thing I know, since this is a tangent, is that tangent is negative in quadrant 2 and quadrant 4. Okay, that's because remember, all students take calculus tells us where it's positive. So I'm looking for an angle in quadrant 2 and an angle in quadrant 4. So when I try to draw this triangle, again, I'm just put it in quadrant 4 because that's how I felt today. Tangent is going to be my opposite over my adjacent. So my opposite side is negative root 3, but then I've got to figure out my adjacent. Remember, any number is, you can rewrite it as a fraction if you make the denominator 1. So my adjacent side is actually 1. Now if I did the Pythagorean theorem, or I used my knowledge of special right triangles, this hypotenuse would be 2. The side that's opposite, my root 3, would be my 60-degree angle. So again, my reference angle here would be pi over 3. So on pi over 3, for this guy, I could make this negative. So I could just go ahead and say that my first general solution would be negative pi over 3 plus 2 pi n. Now I'm going to look for my other guy. So remember, this is my other quadrant where I'm going to be positive. And so again, this is giving me a 60-degree reference angle. And so I should be pi over 3, so that would be 2 pi over 3 would be my other angle. The one interesting thing to notice about tangent graphs is that these two lines right here, that's actually that straight 180-degree line. So they're not 2 pi apart like all the rest of them were. I could write negative pi over 3 plus 2 pi n. I doubt you can see that because that is yellow. Plus 2 pi n. And then I could write 2 pi over 3 plus 2 pi n. But because I know that the period of a tangent graph is just pi, or I know that it starts to repeat after just 1 pi radians, I look here, and since they're right on that same line, I can rewrite this whole solution as just one of them. So let's just use 2 pi over 3 plus pi n, and that would get me all of those solutions. So both of these are acceptable to write. You can write with just 2 pi over 3 plus pi n, or you can write both of those general solutions. Okay, then you could go ahead and find your first 3 positives just knowing that general solution equation. Okay, so now I'm going to look one last one. Again, it's one of those ones where we can't draw a triangle. Okay, if I think about this cosine of -1, I'd have that opposite and no, it'd be crazy. So if you can't draw a triangle, you always think about your OIO chart or you think about your coordinates. Because right here I'm asking what angle is going to give me this. So again, this is asking for an angle measure. This isn't asking for a ratio. So again, this goes 0, pi over 2, pi, 3 pi over 2. And so I can either think about my coordinates, where is my x coordinate, this is an x, going to be equal to -1, or I go on my cosine graph or my cosine column and I find that that should be at pi. Okay, so that's the first solution. I'm going to have pi plus 2 pi n. Now if you notice, there's no other spot in between 0 and 2 pi where my cosine is equal to -1. There's only one solution to this. So this would be my one answer. This would be my general solution. And if they wanted the first 3 positive, we could just go ahead and keep adding 2 pi. So I'd have pi and then 3 pi and then 5 pi. And I could just keep going, but they only asked me for 3, so we're good. So sometimes you may only have one solution equation. If you have a tangent graph, you can just add pi in. If you're looking at a cosine or a sine of a -1, then you're also just going to add pi in each time. And that's all I've got.